DAX data analysis expression is a formula language commonly used in Microsoft Power BI to create calculated measures, columns, and custom tables. Once you understand and master DAX, you have control over your visuals and reports. Also, it gives you more room for performance, better performance, and flexibility within your Power BI reports and generally your Power BI dashboard. So in this course, we started a new course a few days ago where we are trying to learn and master DAX functions in Power BI. So welcome back to Excel Island, where the goal and objective is to learn and master the Microsoft Power BI tool over the next 100 days. And today is day 41. We'll continue from the course we started on day 40, which is DAX functions in Power BI. And in today's live stream, in today's learning journey or today's lesson, we are going to learn introduce to variables that allows you to write efficient DAX functions. Also, all data set exercise files, Power BI files that we'll be using and we've been using over the past 41 days and we continue to use over the next 100 days is already linked under the YouTube description. Do make sure to download those files and practice along with me. So without further ado, let's jump back to learning and welcome to day 41. I look forward to seeing you till day 100 on day 100 here. I look forward to seeing you on the channel. So welcome back to the channel. So I'll just go back to my dashboard currently. We're actually using the DataCamp platform for this learning journey. We're on a course called DAX functions in Power BI. I think we're actually 50 something percent through the whole career track. So I click on the career tracks right here and I go over to data analyst in Power BI. When I started this whole learning journey, I actually started with the data analyst in SQL career track, which ran for 100 days to be precise. So then we moved to data analyst in Power BI. So the next goal, the next objective after completing this data analyst in Power BI is the data analyst with Python career track. So you definitely want to learn Python with me or looking forward to learn and master Python also. You definitely want to subscribe to the channel right now and put on the notification bell so you'll be the first to know whenever I go live or drop a new content on my channel. So I'll just click on data analysis in Power BI. Actually, Champions League is going on right now and I'm currently watching it on my second screen here. But I couldn't just let today go like that without actually learning something 1 hour daily in my for my to upskill myself as a data professional. I'm currently I think Real Madrid have scored. I could see there's going to be an update real quick. So they just scored in the 72 minutes, probably in the 73 minutes, to a corner. I think they are going to have another corner right now too. They're probably winning the Champions League. That's by the way though. So we actually started from this introduction to Power BI. Then we moved down to the whole courses in the career track. We actually did some case study also. So the first case study we did was this analyzing customer churn in Power BI. And we also did another case study called HR analytics in Power BI. So if you actually done two case study so far after completing a couple of courses or in the whole career track, so you definitely want to look at previous live stream to catch up on where we stop. So I'll just continue from this DAX and measures. So this is the second chapter of the course that we're supposed to take. So even though it's showing complete, I'll just retake it one more time because the last live stream there was a couple of challenge. I have to come back and do it again. Okay, so let's continue course. Oh, let me just click on got it. Since we still want to take this DAX and measures back. Oh, that is coming up. Oh, why is it taking time? Let me just load the page very quick. Okay, let's move on to this part of the course. Okay, so welcome to this second part of the course, which is methods to create DAX measures.
Welcome back. Now that you are familiar with using DAX for calculated columns, let's look at using DAX for measures. The first concept we need to understand is implicit versus explicit measures. Implicit measures are automatically created by Power BI and come directly from the database. An example would be if we drag sales to values of a table. Power BI will automatically sum it. Using a drop-down menu, we can define the aggregation, sum, minimum, average, and so forth. Explicit measures is the name for explicitly written measures. An example would be if we calculate total sales as the sum of all sales. Because of their flexibility, explicit measures are preferred. Let's understand why. First of all, it reduces confusion. If we see sales on a report pane, we don't understand what it means exactly. It could be the sum, the average, or something else. Secondly, they are reusable. We can refer to the total sales formula in other measures, such as a calculation for total sales east. Explicit measures can be given a custom name to explain its functionality. Being able to create specific functions for your needs reduces errors and will make maintenance of complex models more sustainable. You'll try this out during the exercises. Using explicit measures in Power BI can be very powerful, but it's important to do so in an organized and structured manner. The first tip is to keep DAX measures grouped together in a separate table. That is because measures are free to move to any table. This is in contrast with calculated columns, which belong to a specific table. The second tip is to format and comment with DAX. Using indentations, you can increase legibility of your formulas, which becomes handy for more complex formulas, or if you haven't looked at a formula for a while. You can also add comments after a double slash to explain what the function does. Some measures might get complex quickly, but luckily we can use variables to make things easier to understand. You can store the result of an expression as a named variable, which can then be used as an argument for other measure expressions. They have four main advantages: improving performance, improving readability, simplified debugging, and reducing complexity. You can define a variable by using var followed by the name and the expression. Finally, we end with a return statement to move back to the main formula. Let's have a look at an example. Let's calculate the absolute sales growth by using a variable. First, we define the variable sales prior year. Using a calculate function, we'll store the sales of the same period last year. This same period last year is a built-in function in Power BI that looks at the sales in the same time frame exactly 1 year ago. Using sales prior year, you can easily calculate the absolute growth in sales. Altogether, it looks like this. You can see the benefit of using a variable in this fairly basic function, but the power of using variables becomes even clearer when using more complex functions, which you'll discover in the exercises. It's practice time. Enjoy!
Practice. Okay, so it says advantages of explicit measures. So as you continue to expand your DAX knowledge, you will find that the measures you develop will become more and more complex. To simplify troubleshooting later, it is important that measures are defined correctly from the start. Explicit measures are preferred over implicit ones. So does the card belong to explicit or implicit measures? So come straight from the database. That should be explicit. Make maintenance of complex models easier. But from the database, that is implicit. So makes maintenance of complex models easier. That's be explicit. Always reuse a measure within another measure. Explicit allows you to change aggregation. Implicit reduces confusion because it is clearly defined. As explicit. Okay, let's log that in. Oh, we nailed it there. So great job. It is clear that using DAX to create explicit measures will help you in your Power BI journey. So let's continue from there. So let's take the second call.
Hello! Let's have a look at how we can actually use DAX to create measures. Just as in a previous demo, I'm working again with the Contoso dataset. Before we dive into it, we refresh our knowledge of implicit versus explicit measures. Let's create a card where we would like to get a count of the number of rows. If we add amount, it will sum it naturally, but we can change the aggregation to count. This is an implicit measure. Before we do the same thing using an explicit measure, we create an empty table in the data pane where we can store our newly created measures. Let's name the table underscore measures. That way we can easily find our measures we are creating without having to look through all tables. Note I added an underscore before measures, so it would appear on top, above all the other tables. Fill in the name of the fact table to count the rows inside. We create another card to verify this. The result is again 3708. Great, both numbers match. Secondly, we want to calculate the average amount for the actual scenario. Remember, there are three scenarios: actual, budget, and forecast. In this case, we are only interested in the actual scenario. We can combine the average with a calculate function to do this. Once again, we create a new measure. Let's name it actual average transaction value. We can press Shift Enter to start typing on a new line, so the formula is easier to understand. Let's start by investigating the calculate function. This formula evaluates an expression in a context modified by filters. We can use the average function as the first argument and a filter as the second argument. We take the average of the amount and filter scenario name from the fact table to be equal to actual. The amount is a currency value, so let's change the format to dollar. We navigate to the report pane so we can add it to a card. The average transaction value is 14.7 million. From looking at the table, we know that the transaction values range from around 20k to over $140 million. It might be worth it to investigate this crazy spread of sales amounts, but that's outside the scope of this demo. The last topic we want to get into is quick measures. We can right-click the measures tables and click Quick Measure. This is a great way to create more complex functions or discover how certain functions work. We have a drop-down of different calculations, and let's go for quarter-over-quarter change. We add amount as the base value and date from the calendar table as the date. We'll leave the number of periods as 1 for now. If we would change this value to 2, it would not calculate the growth compared to last quarter, but to 2 quarters ago. The formula Power BI created looks rather complex and is worth a quick investigation. The first part is a filter on date, so let's ignore that part for now. The second part uses a variable function, as we saw in the previous video. Using a var statement, it defines the amount of previous quarter using a calculate function. The return statement informs us the variable has been defined. Finally, it subtracts the amount of the previous quarter from this quarter and divides it by the amount of last quarter. That is the formula to calculate quarter-over-quarter growth, so that makes sense. That's it for this demo. It's your turn to use these functions to discover worldwide insights about worldwide importers. Enjoy!
Okay, so our time to practice also and put the knowledge to text. So we learned about the difference between implicit and explicit measures. We are also learning how to create variables and quick measures. Creating variables to write better DAX functions and actually creating quick measures within using the time intelligence or the intelligence of Power BI to create calculations in a jiffy. Okay, so let's follow the instruction. So the first instruction is using variables. So as you develop measures that become more and more complex, it may be necessary to assign variables within your measure to simplify and ease troubleshooting. So year-over-year calculations are frequently used in financial comparison analysis to compare two or more measurable events on an annualized basis. You will dive deeper into this in chapter 4. So a year-over-year calculation has already been calculated in the workbook, but it looks rather complex. It's your job to simplify the formula by defining a variable in the function. So open the Power BI file 2.1, which is variable. So you also have access to all the files following the link under the YouTube description. So do make sure to download those files. So let's learn the Power BI file. So following the instruction, so it says navigate to the calculations year-over-year table in the report view and investigate both sales and the year-over-year old. So if you go to the calculations here, you want to investigate sales, this sales. So this sales is just taking the sales, the sum of the total including tax. So I should go to the fact table. So if you scroll to the right here, all the total including this excluding tax, this total including tax. Yeah. So it's just taking the sum. This measure sales is just taking the sum of that column. Why the sales year over year old? So also investigate sales year over year percentage old. So look at this sales year over year old, which is a divide function. So it's dividing the calculated, it's dividing sales, which is the sales measure here, minus a calculated sales in sales period, same period last year, which is a calculate function, which is actually calculating the same period last year. Let's say we're in actually the 1st of June. So we want to calculate the exact sales. We want to compare the sales of 2023 June to the sales of 2024 June. So this is what this formula is calculating. So it's subtracting these sales for the current year from the sales of the previous year and nothing is difference in those records. So this is what this is then sales divided by so this sales, which is our total sales for the year, minus the sales of last year divided by same sale. We calculate sale. This is another calculate function. We just calculating sales. We're going to be returning okay sales same period last year. So we're just repeating this same sales last year calculation twice. So this minus same sales of last year divided by sales of last year is going to give you sales year over year percentage. So that is what this function is doing. This DAX function is doing. So we have invested within the calculations year over year table and name it year over year new. So we write the formula of sales year over year old using a variable and name it sales prior year. Your function should look like the one below. Fill in the blanks. You want to use a variable to create sales prior year using a calculate function. So the goal is to make sure our calculate function is only appearing once rather than twice. And so if I go to this sales year over year new, which I've already done here, you can see we created a variable called sales prior year, which is that calculate function of sales. If you want to calculate sales for period last year, you can see this is what this function is doing. So rather than using this old one here, which is got seems complex. We are actually mentioning calculate function twice. You get it now? We created a new one. Actually mentioned the calculate function once. We made it a variable, and we are referencing this variable here, the one we created with the calculate function, back again within this function here twice. We actually use it twice, dividing same same measure by each other and minusing the result from the what from the actual sale for the year. That's how we calculated this sales year over year new. So if I log that in, which is actually absolutely correct, if I log it in there, so I'll follow back to the instruction. It says format sales year over year new as a percentage. We're going to format our new calculation as a percentage, already formatted as a percentage. Then, so create a line chart, line and stack column chart to overlay sales year over year new on top of sales. We want to compare the sales percentage versus, which is today's year, last year sales to current year sales. I think I already did that here, which is it here, which is what we actually did here. You can see. So if I drill up, you can see. So this is the blue is sales for the current year and sales year over year new, comparing sales to the last period of the year. So if I come back here and say, okay, feel free to create a new page if you don't have space to create a little bit up to the year 2016. So if I click on it, since I have my drill down button on, drill mode is on, I could click on any year within the bar chart here. It's going to go deep into that year. So I could click on the quarter, I could go to quarter one, which is January, February, March. We're actually going to May. We're looking for the month of May, which is quarter two. If I click on this second quarter to go, you can see we have April and May here. So the question asks that what was the year over year growth of May 2016, the last month in the data set for that year 2016. So if I just hover my mouse over it, we're looking at the percentage year over year growth. Okay, so that should be the line chart. You can see that is 1.78%. So 1.7878. Just use the percentage. So we knew, you can see amazing work. It took some effort, but you can already see the value of having clear calculations paying off within two simple clicks. We found the year over year growth for every month. You can see. So the actual growth for this month, you can see there was a drop in this month. The sales year was over $53,000, and the year for that year dropped by for that 2016 dropped to -5%. You can see. While on the other hand, there the year over year growth was, well, at least went higher by 1.78%, which is kind of interesting. So the next instruction says basic statistical measure. So let's explore basic statistical functions. In this exercise, you will use the distance count function to get the number of invoices and the average function to calculate the average retail price. So if I click on create a new table to store the measures, name the table calculations. So to create a new table, we already created a new table called calculations. You can see that there. Then following the instruction, it says create a measure number of invoices to count the distinct amount of invoices in the calculations table. So you can count invoices by using the www invoice ID. Display the measure with 1,000 separator. So we have to count the number of invoices in our fact table. That should be the fact table. I'm going to use this column called uh this invoice ID. So we want to count the distinct number of invoice from the sales table. So to do that, we could go to use the number of invoice calculation here. We just use the distinct count function. We're going to count each unique record in the row. To do that, so we have it there. So we have to display that calculation. It says display the measure with a 1,000 separator. If I click on the measure, 1,000 separator, I could just use a card function to display it. Because we have over 7,000 invoices in our sales table. Then it's also create a second measure called average retail price. To calculate the average retail price, make sure to use the average retail price from the fact sales table. You want to use the average retail price from the what? From the fact sales in this sales table here. The retail price is here, the retail price column. So if you look at the measure here, created called average retail price, you can see. So it's using average retail price, which is average function, the retail price from the fact table, which is quite straightforward there. So it now says create a new page in the report pane and name it retail price analysis. If you want to investigate our retail price analysis, which we've already done here. So the instruction now says create a table visualization with sales territory and the two new measures you created. So we have to use the sales territory, which is our table visual. We drop the table. So we actually drop a table. So we drop a table. In our table, we drop sales territory. You can see using sales territory and number of invoices and average retail price. We drop sales territory right here. We have different sales in our data sets in our company. Then the number of invoices for that sale for that state that we created this measure and the average retail price for what? For each sales territory. So the question now says which region has the lowest average retail price? So which region has the lowest average retail price? We could actually sort this table. You could sort by average retail price. So it's going to sort the whole table for us. I see the region is Southwest region with 6.86 average retail price, which is Southwest region. And boom, we knew that pretty straightforward. And today is the last part, which is the quick measure part. So quick measures are an excellent tool to understand and utilize the full potential of Power BI. They help you create powerful DAX functions with the click of a button without the need to write any code. You should use quick measure to your own advantage while improving your Power BI skills. Instead of writing the year-over-year calculation ourselves, we could have calculated it using a quick measure. Let's calculate it for average retail price to see how it works. If you have lost any progress, close any open report and load quick measure. So I can still use the same workbook that we're using so far. I'll just minimize this our table visual here. Is there an update to the Power BI? This table is always refusing to move. I don't know why. Why the other chart are moving. That's quite funny. I could just minimize it for now. Because it's actually just sorting itself. So let's leave that for now. So let's continue to the quick measure calculation. So I click the calculation year over year table and create new quick measure. So also this year over year table. Okay, we want to create a new measure. So it says select new quick measure. Select average year over year change from the calculation. So we want to select new quick measure. So I'm going to right click and select new quick measure right here. Okay. So it now says select year over year change from the calculation drop down menu. This is the calculation drop down menu. We're looking for year over year change. Okay, did it here, year over year change. So use average retail price and delivery date key to construct your calculated field. So the base value should be average retail price calculation. This is from here, this calculation. And the date key, our date key should be our dim delivery date key here. Okay, so let's add that in and boom. So you can see our calculation is saying average retail price year over year 2. So if I continue, as a reminder, you can enlarge the window by clicking on the full screen button in the bottom right corner. Additionally, you can zoom out to change the resolution. Let's leave that. So in the inspect the formula, this function uses a date add function instead of same period last year function we use to calculate our year over year growth. Sometimes there are multiple means to the same end. So sometimes in Excel, Power BI, all the probably all the OBI tools, there are many ways to scale the cards. They get it now. So there are many ways to do the same thing. So the instruction says it definitely use a date add. You can see it uses a date add function. While our previous calculation, which is this new one, we actually use a what did we use? Oh, same period. We used same period last year rather than a date add. If you actually use date add function here, we are going to arrive at the same results. Okay, so the instruction now says create a cluster column chart to visualize the newly calculated field over time. Got to create a cluster column chart. This is it right here. So our cluster column chart is containing, let me just get rid of this and make my cluster column chart a little bit big. This is my cluster column chart. So for this cluster column chart, we dropped the average retail price, the new calculation year over year calculation, and we dropped our delivery date key to visualize the average retail price over time. You can see it. So I can click on to enable drop down. I can just drill down to quarter. So I can compare the average retail price for different months, different dates, different month, different day, and different quarter of the year. You can see. So I could drill down back up to the year. So the instruction now says in which year did worldwide importers have the greatest year-over-year increase in average retail price? If you try to understand and study the charts, you'll notice there is a negative value here. That means there was a drop, and when we over the each bar, you could see the average retail price for 2014 dropped to negative 0.28%, while this was a big drop at almost 4%. This is negative 3.68. But the positive was this, which is 2015, which is just 0.46%. That is 2015 to be precise. So great job. Average retail price increased by 0.46% in 2015. You could see when we over the chart, we have 0.46%, which is a positive increase in average retail price compared to the previous year. And it said the drop in 2016 looks surprisingly dangerous, though worldwide importers should investigate this because it may hurt their financials in the long term. And we locked that in. So that was how we were able to solve these questions for this second part of our DAX journey in DAX function, introduction to DAX functions in Power BI, where we talk about we learned all about this is the first part. Nope. We learned all about method to create DAX measures, advantages of explicit measures. We also learned about DAX versus measures. We learned about using variables, basic statistical measures, and quick measures. So on the next live stream, we're going to continue from filtering and counting with DAX. Looking forward to that lesson. So that will be all for this from today's live stream. So if you found value in this learning journey with me, trying to learn and skill myself and you yourself in Power BI, do well to support the channel by giving the video a thumbs up, hit that subscribe button, and I'll see you on day 42 live stream where we'll continue our introduction to DAX functions in Power BI journey. And hopefully, I'm going to be seeing you on day 100 of this journey. Thanks for staying to the end of the live stream. You are the real MVP. Do well to get those files, exercise files, Power BI files, using the link under the YouTube description so you can practice and also upskill yourself in Power BI. And I'll see you on day 42. Tomorrow, day 42. Have a wonderful rest of the day.